Hi, today we're going to be doing the Quine-McCluskey method, which is used for minimizing Boolean functions. It's used for functions with 5, 6, 7 or more variables where Carnot maps are no longer effective. Why that is because K-maps use a 2D matrix to represent single bit differences, and that gets more and more difficult as we move past 4 variables. Now, Quine-McCluskey method doesn't have that limitation, so that's what we're going to be doing today. Let's start by looking at the procedure. Now, these steps will get more apparent as we actually try and solve a question, but here's a brief overview of what we're going to be doing. We group terms based on the number of ones, we combine terms that differ by 1 bit, we find prime implicants and select the minimum number of such implicants that cover all the minterms. Now, the best way to get started is to just try out a question, and I strongly recommend that you follow along in a notebook, and hopefully the steps will get clearer as we go. We start by writing out a minterms table, minterm, and A, B, C, which are the variables that our function has been given in. Now, we write out the minterms that have been given to us in the sum of minterms form. So 1, 3, 4, 5, and 6. And along with them, we write out their binary representations 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0. There we go. Now we move on to our first step, which is grouping these minterms based on the number of zeros. So group minterm and A, B, C. Now for group 0, we are going to have minterms whose binary representation has 0 ones. So as we can see here, there are no such minterms with 0 ones. In fact, the only minterm that would be possible would be M0 with 0, 0, 0. And since we don't have that, we are going to leave this group blank. Now we move on to group 1, and we can see that minterm 1 and minterm 4, they have a singular 1 in their binary representation, so it will go into group 1 in the next table, and we write out the binary representation alongside them 1, 0, 0. And similarly, group 2 will have 3, 5 and 6 in it, because 3 has 2 ones, 5 has 2 ones, and 6 has 2 ones. So 3, 5 and 6. Now we have to write out their binary representations as well, 1, 0, 1, 1, 1, 0. Now that's our first step done. We move on to the next step, which is combining terms that differ by a single bit. So we make a table that's very similar to this one, group minterm and A, B, C. And the only difference over here will be that we're forming minterm pairs. Now we start with group 0, and to form group 0, we look at the previous table and find group 0 and compare it with its adjacent group. And since we don't have any elements in group 0, we are going to leave group 0 blank here as well. So now for group 1, we are going to locate group 1 in the previous table and compare it with its adjacent group. So we compare elements of group 1 with group 2. And the comparisons will be made in such a fashion: 1, 3, 1, 5, 1, 6, 4, 3, 4, 5, and 4, 6. Now, all of these comparisons will have to be validated and checked if they have a single bit difference, and only then they'll be transferred onto the next table. So we start out by checking 1 and 3. So they have no difference here, 1 bit difference here, and no difference here. So 1 and 3 only differ by 1 bit, so they classify as a valid pair to move on to the next table. And how we are going to represent their binary representation is 0 blank 1, because the first bit doesn't change, which is a 0, the last bit doesn't change, which is a 1, and the middle bit does change, which has been represented by a dash. Now similarly for 1 and 5, we are going to make the comparison. This bit does change, this bit doesn't, and neither does this bit. So we are going to write it out as dash 0, 1, which is achieved by 1, 5 minterm pair. Now we compare 1 and 6. This bit changes, and so does this bit. So this won't be a valid pair to transfer to the next table. Now we've made all the comparisons between 1, so now we will make the comparisons with 4. So 4 and 3, they differ by 1 bit, 2 bits, and 3 bits. So this won't qualify as a pair to transfer to the next table. Now 4 and 5, This bit doesn't change, this bit doesn't change, but the last bit does. So we're going to write them out as 1, 0, blank, and it's achieved by 4 and 5. Similarly, 4 and 6, this bit doesn't change, this bit does change, and the last bit doesn't change. So we're going to write it out as 1, blank, 0, and 4, comma 6. Now this step that we just did is a recursive step that we have to keep doing until we can make no further comparisons between groups. So we start by making another table, group, minterm, pairs, and A, B, C. Now if we were to construct a group 0 in this table, we would look at group 0 in the previous table and compare it with group 1. But we can see that group 0 doesn't have any elements in it, so we can't make this new table. So this would be our terminating step. So now after this, what we do is we check for all the minterms and implicants that have been covered by the minterms and implicants in the next tables. So we go in a reverse order, and for example 1 and 3, 1 comma 3 has been covered. So in the previous table we put a check against 1 and 3. Similarly 1 and 5, we need not put double ticks since it has already been covered. 4 and 5, 4 and 5, and 4 and 6. And if we had previous tables, we would also have to check for minterms and implicants being covered in the previous tables. But since we don't, we can move on to the final step, which is writing out the prime implicants table. Prime implicants. Alright. Now we need to find all the minterms and implicants that haven't been covered in the previous tables. As we can see, neither of the implicants in the last table have been covered, and all of the minterms in the previous table has. So we are going to write out the implicants in the last table as follows: A bar C, B bar C, A B bar, and A C bar. Now, how we come up with these implicants is by looking at the relation of each of these bits and also whether or not they have a dash. So, for example, this first 1-3 pair, it's inversely dependent on A, directly dependent on C, and not dependent on B. So, inversely dependent on A, directly dependent on C, and it doesn't have a B in its implicant. Similarly, for 1 comma 5, we get inversely dependent on B, directly dependent on C, and so on. So now we list out these minterms and the ones collected from the previous table, which we don't have any of because they have all been covered, into the prime implicants table. So we write out A bar C, B bar C, A B bar, and A C bar. Now, after this, we write out all the minterms that have been covered by these implicants. So 1 comma 3, as we can see over here, 1 comma 5, 4 comma 5, and 4 comma 6. Now, the next step would be to write out all the minterms given to us in the function. So that's 1, 3, 4, 5, and 6. And we write them out with a little bit of space between each of them. So now what we do is we look at the rows of each implicant and cross out every minterm covered by that implicant. So for example, A bar C covers 1 and 3, B bar C covers 1 and 5, AB bar covers 4 and 5, and AC bar covers 4 and 6. Now we start to choose the essential prime implicants, which are basically the prime implicants whose rows correspond to x's that are alone in their columns. So for example, 3 is alone in its column, so A bar C would be an essential prime implicant. Similarly, this cross is alone in its column, so AC bar would be a prime implicant. So we mark these with an asterisk, and we also circle the crosses that have been chosen. Now, the next step would be to mark all the minterms covered as a consequence of selecting these prime implicants. So we dash out the entire prime implicants and circle the crosses that have been covered as a consequence of choosing these prime implicants. Now, what we do is we put tick marks above all the minterms that have been covered. So 1 and 4 have been covered as a consequence of choosing the prime implicants that cover 3 and 6. The only minterm that hasn't been covered is 5. So to cover this minterm, we have to choose another prime implicant, either of B bar C, as they both have across on 5. So we can choose either B bar C or AB bar, and we are going to choose AB bar in this case. So we can say that these two crosses have been selected and the minterm 5 has been covered. Now, once we're done covering all these minterms, we can write out our function, which is f is equal to, and we collect all the prime implicants from the prime implicants table with an asterisk next to them. So a dash c plus a b bar plus a c bar. There we go. So now if we write out the truth table, which is here, we can see that all the minterms that are corresponding to ones in the truth table, so that would be M1, M2, M3, M4, M5, and M6, all the ones corresponding to ones in the truth table are the ones that have been given in our original function. The ones that have been given in our original function. So we have successfully recreated the function and minimized it using the Quine-McCluskey method. So now we'll look at the Quine-McCluskey method for 4 variables. So here's a solved example for Quine-McCluskey method for 4 variables. We have been given a function, and again the first step is to write out a minterms table. So we've written out 3, 5, 6, 7 all the way up to 15. Then we form groups based on the number of ones. So as we can see, minterm 8 goes to group 1, minterm 3, which has 2 ones, goes to group 2, and so on. Now the next step is to form minterm pairs. So as we can see, 8 and 12, for example, which is here and here, these differ by a single bit, and that is the B bit. So we have written 1 blank 0 0. And similarly for the rest of these, we have formed minterm pairs. Now once we have formed all of these minterm pairs, we have ticked all the minterms that they cover, and here we have our new table. And the next step would be to make another table that looks very much like this one and form pairs of minterm pairs. So in this case, for example, 3, 7, 11, and 15, they are here and here. So our job is to form minterm pairs preserving the blanks. So if there exists a blank over here, it'll only classify as a valid minterm pair if the same bit has a blank as well when we're making the comparison. So 3, 7 and 11 and 15 does classify as this, as we can see. 0 and 1, the first bit differs, the second bit is already a dash, so we preserve that, and the third and fourth bit are 1 each. So we write out blank blank 1 1. So once we've done this enough times, we get this as our terminating step. So then we go backwards, collecting each of the implicants from the tables that haven't been covered, and we write them out in the prime implicants table. Also, we write out the minterms that have been covered by those prime implicants, and once we've done that, we list out all the minterms over here and put crosses next to the minterms that have been covered. Now, the next step would be to choose our prime implicants that are essential for covering all the minterms. So 3 only has one x in its column, so CD is going to be a prime implicant. Similarly with 5, A bar BD. Similarly with 6, BC, and 8 and 11, they all contribute to these essential prime implicants. Then we slash out the rows corresponding to the prime implicants and check off the minterms that have been covered as a consequence of choosing the prime implicants. So for example, 7 has been covered by CD, BC, and A bar BD as a consequence of choosing those prime implicants, and so on. So then we put ticks on all of them, and in this case we don't seem to have any remaining minterms that haven't been covered, so we don't need to choose anything besides the essential prime implicants. Once we've done that, we write out our function like this, and we will collect all the prime implicants here that have been marked with an asterisk. So we get this as the function, and then when we write out the truth table, we see that all the minterms corresponding to ones in the truth table are the ones that have been given in the original function. So 3, 5, 6, 7, 8, 11, 12, 14, 15. 3, 5, 6, 7, 8, 11, 12, 14, 15. There we go. Now we're going to move on to Quine-McCluskey method for 5 variables. So here we have a solved example for Quine-McCluskey method with 5 variables, and as you can see we can have minterms all the way up to 31. So we list out all those minterms in a minterms table, then we form groups based on the number of ones in them. So for example, the minterm 0 is in group 0 because it has 0 ones in it. Similarly, the minterm 31 has 5 ones in it, which makes it a part of group 5. Now we move on to the next table, which is formed by looking at the members of the previous table, and we look for 1-bit differences in adjacent groups. So for example, 2 and 10, 2 and 10, 2 and 10, they differ by only 1 bit, which is the bit B. So we write it as 0-010. And similarly, for the next table, we make pairs of minterm pairs. For example, 0, 1, 2, 3, 0, 1, and 2, 3. So when we make pairs of minterm pairs, we are meant to preserve the dashes and then look for 1-bit differences in the rest of the bits. So over here, this dash is preserved, this is a 1-bit difference, and the rest of the bits are same. So we look at the next table, and as expected, this dash is preserved, this dash is the new bit difference, and these are the remaining bits that remain the same. So now we do this until we find the terminating step in which we have only one group. And in this case, we have a lot of repeated implicants, which will count towards just one implicant in the prime implicants table. So now we start to make the prime implicants table. So we go back through the tables and look for all the implicants that haven't been covered in each of the tables, and we list them out in this prime implicants table, and then next to them we write out all the minterms and put crosses in the corresponding positions. Then we find out the essential prime implicants, which correspond to the x's that are alone in their columns. So a bar, c bar, and a bar, b bar, d, e bar are the prime implicants in this case. Then we mark all of the minterms covered as a consequence of selecting the prime implicants. And finally, we choose the remaining implicants to cover the minterms that haven't been covered yet. So in this case, the remaining minterms that are all on this side have to be covered by the fewest possible prime implicants. And in this case, we end up finding that C bar, D bar, E, and then A, B bar, C, D bar, A, B, C, E bar, and A, C, D, E are those remaining implicants. So after this, we write out the function by listing all the prime implicants that have an asterisk next to them. And sure enough, if we write out the truth table, we will find the minterms corresponding to the ones that have been given in the question. So that was Quine-McCluskey method for 3, 4, and 5 variables. I hope you understood it. If you want to practice this, you can of course take the K-map questions that you have been given and solve them using Quine-McCluskey method, and hopefully it'll be much clearer then.